All right, so here we're having a look at bearings. Now, bearings are basically just directions. And the reason why we use bearings sometimes to give a direction is because if you tell somebody to go left or right, it depends, that depends on what direction they're already facing. Whereas if you were to tell them to go, for example, north, north's always the same, right? And what bearings are it's a bit like north, south, east, and west. It's always the same, but it's given in terms of angles instead of words like north, south, east, and west. I think what I'll do is I'll lay out some of the rules about bearings, and then I'll do some questions, and hopefully they'll click into place. So the first thing is that it's an angle, and it's always measured from north. So the key first thing is that it's always measured from north. The angle is always measured clockwise, and it's always given as three figures. They're called three-figure bearings because they're always given as three figures, three numbers that make up the angle that you're telling someone to point in. But those might not make sense until we actually start doing a question. So let's do one. This question here is, we've got 2 points, we've got A and we've got B, and we're being asked, what is the bearing of B from A? Now, the first thing is we have to be really careful about the phrasing of the question. We want to know the bearing of B from A, which means we're going from A to B. So the first thing we'll do is draw a line connecting A and B. Now, normally you do this with a pen and paper, but I'm just going to do the best I can with showing you how to do it on screen. So you get your pen, you draw a line from A to B, and we need to know what angle that is from north, because that's our first rule. So the next thing we'll do is draw a north line. Ooh, I don't want to include the protractor there, sorry. We'll take a north line and draw it at our starting point, because we need to measure this angle, clockwise from north, like that. So to measure that angle, we'll take our protractor. Now you'll see it's already vertical, it's already pointing upwards because we need to measure from north. So we need the 0 of our protractor to line up with north, which means it has to be vertical like this. So take the point of your protractor and make sure it's lined up right with the point of your angle, as precise as you can be. I reckon maybe about there, should be right. And then we measure the angle. The angle, if we go round from 0, round the outside, is 75 degrees. But if we look at our last rule, rule 3, is that it has to be 3 figures. So what happens when you have an angle like this, which is only 2 figures, is that you just put a 0 in front of it, and now it's a 3-figure bearing. The answer is 075 degrees. So that's bearings, and the reason why it's useful, again, to repeat what I said earlier, is because if you tell someone to go in a direction of 075, on a bearing of 075, then what they're going to do is they're going to point to north, turn 075 degrees, and then that's the direction they need to go in. Let's look at some other examples. This question down here, what is the bearing of C from D? So again, what we're going to do is we're going to draw a line that starts at D, because we're going from D. So it starts at D and goes to C. We're going to need another north line in, so I'll just take my north line and put it at my starting point here. And this time the angle that we're measuring comes around like this, because like we said before, it's always clockwise, so it comes around like this, clockwise from north. Now, we've only got a 180 degree protractor, and you might have a 360 degree one, but it is really handy to know how to use a 180 degree protractor to measure this angle, which is bigger than the angle my protractor can measure. Because we know that 180 degrees looks like this. So we know that a line going straight down, that angle is 180 degrees. So all we need to do is measure the extra part of our angle and then add it to 180, and then that's the size of my entire angle. So to measure this little extra bit, I'm going to have to flip my protractor upside down and then measure like this. I'll line up my protractor so that 0 is at the bottom, measure around the outside, and to me that looks, sorry, my protractor's not quite lined up there. And around the bottom, going around the outside of the protractor, that looks to be 60 degrees. So I'll just get that protractor out of the way. 60 degrees is this little extra bit, which means my entire angle is 180 plus 60, which is 240. So what is the bearing of C from D? It's 240 degrees. That's the bearing. Right, now we have one last question to talk through. I want the bearing of E from F. So again, I'll take a line starting at F, because we're going to E from F, like that. Draw it over to E. There we go. I'll need another north line in, so I'll take this and draw a north line in at my starting point, about there. Let's just see if I can make that a bit more precise. Right there, I think. And we have to measure the angle clockwise from north. So we're going clockwise from north. That's the angle I'm trying to measure. And a bit like last time, it's bigger than 180 degrees. So if I section this off, I know that this part of my angle is 180 degrees, and I have to measure this part. So I'll take my protractor, which is already the right way round from our last question, line it up like that, and coming around the outside of the protractor from 0, this angle looks to be 120. So I'll get that out of the way. That angle is 120 degrees, which means the entire angle is 180 plus 120, which is 300 degrees. So what is the bearing of E from F? It's 300 degrees. And that's bearings. So the 3 rules, you're always measuring from north, you always measure clockwise, and it's always given us 3 figures. And all a bearing is a direction. You're just telling someone to go in this direction. And that's bearings. Hope that helps.